Hello everyone, welcome to this video for the Cascade level control lab. So keep in mind we are still doing an on-off type system. But we're just trying to minimize the deadband or the delay time in response, and increase the accuracy of the control system. So for this one, you need to make sure that your PLC has the HMI program inside of it. It's the one I choose for you guys to work with. You can do this with the manual or the push button lab, but it does work a little bit more nicely with the HMI. Okay, so here there's a little brief description of what we can use and what we need to achieve. We're going to try and turn it on and off at 20 gallons of water, but we also want to modulate or step the frequency command to the pump and vary the speed of the pump as well as trying to maintain that set point. So we're adding a level of difficulty essentially to this lab, but you will definitely have time to design this on your own and see it function, and then we're going to change some of the set points and see how the response time reacts to that. Okay, so here you're going to design the circuit that I'm going to show you guys. It is a little bit extensive, so if you want to wait until you are in lab to finalize it, that's fine. But you should have an idea of what you're going to be expected to do for this lab. Okay, and let's take a look at some of the programming that we need to change inside of RS Logix. So again, here you can keep this start and stop in if you like. This will be basically a fail-safe that will start the pump or stop the pump should we get to our set points. And for the modulating power, all right, once the start command is hit to tell it to turn on, this equal block right here will say, okay, DP level to PV needs to be equal to 10. And then what I did was I created some internal relay, ladder logic relay with contacts and internal bits to add to this frequency command. So if we're at 55, we're gonna add 5 to that and send it to. So if source A is 50, we're gonna add 5 to it, and then the frequency command will be 55. Okay, I'm not live with the controller right now, so it's not updated. In general, though, to add a bit inside of here, so as an example, I already have CR_9 created, but if I want to create CR_02, let's say, all right, just by creating that, the program does not yet have it saved in its program tag list. So you're going to want to click on it after you've created it, okay, and let's see here what's going on. No. All right, so once you've named it, you want to right click on there, and then it's going to bring up the option to create a new one. So you want to select that option, and then just hit the drop down for create, and you could hit create and close or create and open new. What this is going to do is tell the program that we have a new Boolean algebra equation or a new Boolean algebra expression. So basically, if CR02 is energized, it will activate this contact, and then it will add to the frequency command or the frequency reference. Okay, so once you name it, you want to right click on that. It'll pop open the option to create the new tag, and then you just want to hit create. Now the program actually has it live. Okay, so we're going to do that a couple of times at the high and low, and we're going to basically modulate the speed of the pump. As it approaches its 0, we're going to start to turn it on, and then as it reaches its maximum, as it approaches its 10, which is its low point, it'll start to slow down, and then as it ramps up, we'll get closer to the set point and not overshoot, slowing the pump down again. All right, so we're going to use some of the equal to blocks. Again, you can use less than or greater than. We're going to use a couple of the add function blocks in there, a couple of internal control relay setups, and that should get us to the cascading level control that we're trying to achieve. Thanks for watching. Please make sure you review this video before you come into lab. Thank you.